So guys, when I first did the introduction to this channel, and I've mentioned on the odd occasion as well on videos, the quite simple fact is that when you're repairing electronic equipment, you're not going to repair everything. You can't repair them all. And yet when you watch repair channels on YouTube, it would appear that you can repair them all. And that isn't the case. And I don't want you to start getting disappointed when you find stuff that you can't fix. And there's generally 4 reasons why you can't fix stuff. Yeah, can't fix. Yeah, the first reason why you can't fix stuff is can't get the parts. You cannot get the replacement parts. You know what's wrong with it, but you can't get the replacement parts. Yeah. The second reason is that you know what's wrong with it, but it's not something that can be repaired. Burnt out circuit boards, traces, damage, previous repair damage, to the extent that you can't recover it. Yeah. So that's just effectively, I think we'll put it as beyond possible repair. You can't fix it. It can't be fixed. Another good example of this would be on an LCD screen, where you get the flexible tab bonds, the ribbons between the screen and the circuit board, and mounted on there are little chips, and it's not possible to change them. You can't replace those chips. They're bonded to the tab, or the tab isn't bonded to the circuit board anymore, and you're getting vertical lines on the screen. That type of thing. And as I say, burnt out components that have effectively burnt through the circuit board. Those are beyond possible repair. The third one is similar. Beyond economical repair, yeah? Beyond economical repair. This is where you trace the fault and you know what is wrong with it, but the cost of the parts is too expensive to make the repair worthwhile. Graphics card with burnt out GPU or blown GPU. You may be able to get the GPU, but it could be that the cost of getting the GPU is just too much to contemplate repairing it. So that's the third one. And the fourth one is can't work out what's wrong with it. What's wrong with it? Okay, this means that no matter what you've done to trace the fault, at the end of the day, you just cannot work out what the problem is. And those are really the 4 main cases. You could include, you can say A-Rich as a 5th one, and that is don't have the equipment or skills to undertake the repair. But I'm hoping, yeah, sure, when you start, and depending on what resources you have, but the whole point of this repair, buying stuff and repairing it, buy it, repair it and sell it, is to make more money to buy the kit. And the whole point of this training is to learn the skills. So although that might start off as an initial thing, it's real, hopefully that will become less. That's something you can do something about. These are the 4 things, something that you can't do anything about. So the video you're going to watch now is a laptop repair. In this video, I'm trying to do something interesting, and I'm going to try to actually repair an LCD screen that is blank. It has no image on it, yeah? And I know the laptop works. You'll see this in the video. I know the problem is the screen. So I've tried to repair this. And in the end, to save your time, if you don't want to watch such video, you'll see that I can't repair it for one of these 4 reasons. And I'm going to upload the video because I want you to see the reality of doing this sort of work. So I hope you enjoy the video, and at the end, please put your comments on YouTube and let me know what you think, and let me know if maybe you think, yes, I could have repaired it this way or that way. So anyway, enjoy the video and just let me know what you guys think. See you now. So guys, I thought we'd look at this HP laptop today. This is an interesting one. We could call this a bit of a challenge if you like. This came from a guy here who repairs computers, laptops and such like, but he's not a component level repair engineer. He has another guy that he passes stuff to which he can't repair himself, and that guy's had a look at this one, and then he called me and said, "Hey Rich, can you have a look at it?" So the story with this is basically that he's had a faulty screen with lines across the screen. So he bought himself a replacement screen, put it in, and it worked. Then he put it on one side for a couple of weeks. He was pushing for sale. It's i5 V Pro Intel, say Hewlett Packard. He got a buyer for it, went to demonstrate it, and the screen was blank. Well, I say blank, the backlight works, but there's no image. So he brought it to me, and he didn't tell me this. He just said, "Oh, the screen was faulty, so I bought a new screen." And then it went blank. I thought, "Oh, maybe it's the cable then." So I didn't even look at it apart. I just didn't look at the old screen, just his new screen. It was blank. You connect to VGA, connect to an external monitor, it works. I thought, okay, maybe it's the cable then. So I got a cable for a few pounds and stuck that on, and it still didn't work. I thought, "Oh, that's interesting." And then I actually got the old screen, plugged it in, and found that it does work on the old screen, but there's lines on the picture. So it's not the cable. I mean, I should have looked at it properly to start with. But anyway, the challenge is, can we fix a laptop screen? Well, that should be interesting. What do you think? Can we, can't we? I don't know. So this is the replacement screen, and this is the original screen. And if I just power this on, I'll just check to make sure the video cable is attached to the screen. Yeah, it is. So this is the original screen. So if I power this on, we should get a picture on here. There you are, HP. Can you? Yeah, hopefully you can see all the flickering lines at the bottom. That's the problem with the original screen. So just switch that off. So that's what was wrong with the original screen. Let's power it off for a minute. So this guy got himself a replacement screen off eBay or somewhere, I imagine, and he fitted the replacement screen, and it says it worked until he put it on one side and left it for a little while, and then it didn't work. So this is the replacement screen which he got. And this one, it lights up with a few horizontal lines. It lights up, so the backlight's working, but that's all. There's no video on this one. So that's what we have. Can we fix the laptop screen? Well, let's power it off. I'm guessing we need to have a look under here. Is the truth of that? Because we know the video's coming in working because the screen gives a picture, so we know that that's okay. So the problem's here somewhere. The backlight works, that's fair enough, that's coming in here. So something I suspect is wrong on this circuit board. I don't think it's the screen panel itself. I mean, normally if a screen panel fails, it's, you know, giving lines on the screen. It could be. I don't know. So let's see what we have here. So there's a circuit board here. It's stuck down with a bit of tape or something under here. It's a bit sticky, that. See if we can just get that off from there. So I've looked at a few TVs. I don't repair TVs in the workshop. I never mentioned this before, for two reasons. One, I don't have enough space, and two, I had too many complaints from the president of the community dad, who doesn't like me operating in technical services from the top floor of the shopping centre. He said this is the main floor. I say top floor. This building kind of built on a slope, so this is the floor people come into the building on. Basically, the main entrance is on this top floor, then the floors go downwards. So he doesn't like me repairing stuff in here, and I kind of eventually came to a compromise with him on the basis I wouldn't fix large stuff such as TVs in here. Okay, This seems to be held on by tape, and I guess maybe I can just leave that in place if I'm lucky. If I can get the connector to come through here. No, that's not going to be easy. I think I'm going to have to take this off. Oh well, the screen's not working, so you know, no big deal. Let's take the one off the screen with the lines on first. Again, it's a very sticky part here. Okay, that's come off. I think this is just held on with tape, yeah. Nothing very complicated there, it's just tape. I'm sure we can reapply that if we manage to fix the other one. Okay, so they held on with tape, so we need to take the tape off this. I think the easy way to do this is going to be to unscrew the 6 screws that hold the screen onto the bracket. That also going to make it a bit easier if we want to swap between the two. Give me a moment, guys. Let's just put the air conditioning on in the workshop. It's getting a bit warm in here. Okay, so screwdrivers, a little plastic tub for putting the bits in, so we don't lose anything. Let's see if we can just. That's too big. Just get this screen panel off here. I should have gone and Googled actually, just YouTube, see if anybody can give any suggestions on repairing the laptop screens, but you know, well, in for a penny, in for a pound now. Let's just throw caution to the wind and let's see what we can see, and then maybe look on YouTube afterwards when we can't fix it. Who knows? Okay, so let's just get these screws out of here. A little bit fiddly, but they're coming. Oh, we've lost it somewhere. We've lost one somewhere. Oh, I see it. It's stuck there. That's where it went. Okay. That one's gone down here. Just one left. And now we have the screen panel. I think we'll get a cloth or something to put underneath this, just to stop it getting scratched. Just an old cloth, but it's probably a good idea, so we can work on that. There we are. Of course, we need to take this off now. That's actually ripped the plastic rather than come off as we want it to. Well, that's interesting. This one has like a tab thingy, the other one didn't have, as far as I can see. Okay, that's going to be fun. I don't think that does anything particularly useful. I'll take it off. I'm not sure that's doing anything useful at all. There we are. Okay. So there we have the screen. Right, let's have a look at what we've got, and maybe we can start checking some things and see if we can see what the problem is. I'll zoom the camera down so we can see a little bit better what we're doing. Just give me one moment. Okay. So we can see a little bit clearer now. I've looked at a few TVs before, so I don't repair TVs anymore, but I have repaired them in the past and had a look at them. So what do we have? Well, we have a ribbon cable going up here, which I'm assuming this white line shows where it's inserted, and that seems to be held firmly in place. We have this little PCB and then the actual panel itself. So behind the panel will be LED lighting, not LCD, LED lighting. I'll get the center set in a minute. And this is like a controller board. So coming in is your power. There's only one cable coming from the laptop, so this is the power for the backlight, controls the brightness of it, and effectively sends the data into here. This is what would be called a TCON, timing controller board, basically on a TV. So the data will come in here, LVDS, low voltage differential signal, and that data will be processed by this board, and going down these three ribbons effectively is going to be the video. You can possibly just see actually that there's something inside here. Yeah, that's a chip, and they're called chip on flex, COF, and these quite often fail on LED and LCD TVs. You can see that one probably quite clearly, and these sometimes fail, and that's what gives you vertical lines on the screen. The same, the bond, this is called the tab bond, which bonds the screen to the circuit board. These fail as well sometimes and give vertical lines on the screen, but we don't really have that. We just seem to have like pretty much no picture. So I think what we'll do is let's put the working one, when I say working, the one that works but gives us a picture with vertical lines on it. Let's put that one on, and let's have a look to see if we can see any voltages coming in here, anything useful. It looks like just before I do connect it, where is the connector? Yeah, you see like there's like a thick track here, so that was like a power rail. This looks like a power rail ground, and there's some information here which is quite handy. It's saying VBL, pulse width modulation, that'll control the brightness of the screen. Yeah, so there's some signals here. That's quite useful. That must be referring to these dots here. So we have some test points. That's quite nice. Let's see if we can do something with that. I'm just going to try just to adjust the focus again a little bit, otherwise we'll have to get us under the microscope. 1 second. Okay, I think that's focused pretty well actually. I think we can work on this. So let's just absolutely double check. This should be the screen that gives a picture, but it's got lines on it. So let's just have a quick look at what we have on here. I'll probably have to zoom this out for you to see, but you'll probably see a picture. You should be able to see if a picture comes on this. Turn the power on. Yeah. This was the one that's actually got a picture on it and lines on the bottom. Okay, so we know which screen that is. You can possibly see that maybe. It's just saying no disk error. Say no disk now because I haven't got the hard drive connected. Okay, so that's the one that gives a picture with lines on. So yeah, as I was saying, down here, very handily, we seem to have some test points, and looks like there's 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 2 here, that's ground. Another one there, V12, PVDD, and then all these ones. So then what we'll do with this is we'll go across all these test points with the multimeter on the voltage range, and we'll have what we've got and we'll make a note of them, and then we'll do the same on the good board. I'm assuming these test points are probably all directly coming in from here, so I expect them to be kind of the same. But let's have a look and see what we can do. Okay, so on my camera on the multimeter there. Hope you guys are preferring this setup. I think it's making it a little bit easier to show you what I'm doing. Move the wire away from the camera. I'll probably end up knocking the camera over, of course. So yeah, let's have a look what we've got here and see what we can see. Piece of paper and a pen, that's going to be handy before I just do this, so I can actually make a note. Well, just give me 1 second. Okay, got myself pen and paper. I'm also just going to put like a mark on this, just an X. That's to remind me which one actually gives the picture, because it's very easy if you start swapping these back and forth to become very confused about what's going on. Okay, let's see what we got. There's a ground point. I can see a ground, but I'm hoping that all these metal points here are actually ground as well. Well, anyway, we have a ground there. That's ground. Let's just go across all these, what we have. 19.5 volts. Can you see that? So that's the first one. That's VBL. I'm just making a note of these 19.5. Okay. Next one is PWM. This should be the pulse width modulation for the backlight. I'm expecting to read a few volts on this. The oscilloscope would show us a signal on this, but let's have a look. Pulse width modulation. I'll see if we can fix this without an oscilloscope out of interest. Okay, so here's ground. And we have, push this damn thing out of the way, 3.125 PWM. Next one, BLEM. This is Backlight Enable. I'm expecting this to be 3 volts or 5 volts, some sort of voltage. Let's go on the ground again. Yeah, 3.3. I'm just moving my meter, so that's a ground point. That's the easier. Okay, so Backlight Enable. Yeah, 3.3. That sounds sensible. If that was actually active low, so the enable is when it's 0, that would BLEM would have a line across the top of it, or an asterisk or a hash in front of it normally. Next one is HPD. Don't we know what that is, but let's have a look. 1, 2, 3, 4. HPD. We've got that one. .5, okay. HPD 2.5. Next is VCC. This is a power rail. 1, 2, 3, 4, 5. This is up here somewhere. 3 volts or 5 volts? Or nothing. That's interesting. Oh, sorry, 1, 2. This is VPN, not VCC, not VCC. So that one 0. Next one 3.16. That's VCC. Okay. So next two 3.16 0. What else do we have? After that, we got all these DPRX. 4 signals called DPRX, so let's have a look at those up on the pads up here. See what's on these. 2.97 minus 0.14. Okay, 2.97 minus 0.14. Last one's this one. Was that one 2. What was the 2.7? This one 0 0. Okay, last two is 0 0 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have a few more. We have some over here. T-card. Can I read them? Let's have a look at these 4 dots here. Let's just see what they are. I'll draw 4 dots on my bit of paper. I'll draw a T-con chip, which stands for timing controller, by the way. That's this one. 1, 2, 3, 4. So at the moment we're just trying to find some difference between these two screens to see if we can find any difference. So what we got? 0, 0.919, 0.311. Okay, 0, 0.919, 0.311, I think that was just. 0.919 again. That's those 4. What else do we have? We have a few more around here. This one, PWDD 3.14, PVDD 3.14. What else do we have? I think for now we'll start off with those, and we'll see if we see some difference. If not, we'll have some of these around here, see if these will tell us anything. But we have some. Okay, let's start off with that. Switch it off. Okay. Let's have a look at the other screen. So this is the one that lights up but gives no picture. I hadn't realised the battery's still on this thing. Okay, lights up and gives no picture. Okay. Let's have a look. Same place, same voltages. Let's give them a look. So we should have, and I've written them down. We should have 19.5. Yes, close enough. 3.125. Close enough. 3.3. Good. 2.5. Close enough. 0. Yeah, good. 3.16. Close enough. 2.97. Close enough. Minus 0.14. Yeah, close enough. And those two are both 0. 0. 0. PVDD down here is 3.14. Call that good enough. And then down by this T-con we had 0. 0.919. Close. 0.919 again. 0. That's interesting. Oh no, sorry, it was 0.31 on the other one. 0.307. Yeah, that's so those all look the same. I think what we need to do is continue around this board and have a look at the other test points we can see, and see if we can actually spot something that is not the same. I think I might just take a photograph of this, and then yeah, I'm going to take a photograph of it, and then I can just draw on the photograph. So give me a few moments, I'll give myself a photo and print it out. Okay guys, what I've done is I've basically printed a picture of the board, and I can see that there's a lot of test points on this. So what I'm going to do is now I'll pause the video, and I'll just I'll just go through all these test points, and I'll make a note on here of all the voltages, and then we can put the other screen on. This, by the way, now is the one which has the picture, so I'm effectively measuring off a good one, even though we know the screen itself's faulty. And I'll write all the voltages on here, and then we'll put the video back on with the other one, and we'll go across and we'll compare with this one and see if we can see any difference between the two. See you in a few minutes. Okay guys, so basically I took a photograph and printed a picture of the circuit board, and I went across all the test points on the working one, or the one that gives a picture, although it's a bad picture, bad screen. and I made a note of all the voltages on all the test points. I then took a photograph of the board off the other one. Well, no, it's the same photograph, just printed it twice. And I went all the way across the one that doesn't give a picture, just the backlight, and checked all the voltages on that one. And basically, the truth be known, they're the same. But this one has a blank screen with no image, just a backlight. The other one gives a picture. But I can't see any difference on this with the multimeter. Certainly I can't see anything there to say there's a difference between the two boards. So I think we can have to assume that all the voltages are present, which is a good thing, but it doesn't really help us to find the fault. So I think next we have to have a look at the data sheets. I'm just checking if these things are warm, by the way. See if any data, they're not. Normally I expect them to be a bit warm. I think we're going to have to look up the data sheet of some of the chips on here and see what we actually have. And then once we've done that, maybe we'll find some points we can test with the oscilloscope to see why we appear to have all the voltages present but no signal, no data on this one. So we'll switch this one off. Let's hold the button for a moment. I switched it off this time, switch it off. And we'll have a look at this under the microscope, and we'll have a look to see if we can identify any of the chips on this board and find out from the datasheet what they actually do. Okay, so let's go over to the microscope cam. I hope it hasn't frozen like it usually does. One moment. Yeah, it's frozen. Just give me a second and I'll restart the camera. Okay, so what do we know? Well, we know that the data, the video, comes on this connector, and I'm assuming a few of these pads here actually where the data is coming in. We do have some markings, DPRX, such like. Maybe if we looked at those abbreviations, it might tell us something. But we have some chips on here, so let's have a look to see what's actually on the board, and maybe this will give us some indication as to what's wrong with one of them. This, I'm fairly sure, is going to be what's called a TCON. In fact, I think it even says IC TCON, timing controller. So this chip should be very much involved with generating the image. The one over here, this one, I suspect this is to do with the gamma correction. This is basically sets a lot of voltage that control the brightness of the screen and control the image on the screen. But in the region of this chip, there was a lot of test points here where I kind of found like descending voltages, if you like. If I just find the image, I made a note of all these. Yeah, it's too big with the microscope, but basically I found like a lot of voltages on here which kind of like descend in order. You see 278, 175 and such like, and all these varying voltages here. See 6.16, 6.42, 7.04, 6.79, 7.88 and so on. These are sort of voltages I'd expect to see from a gamma chip. There's a few more around here. So I think that's basically all these test points here. And in fact, they say like RG. These are gamma voltages. So we can look up this chip, but basically the fact I've got a load of ascending or descending voltages here suggests to me that the gamma chip is working. If not, then you usually get like a picture, but the contrast is all wrong, or the brightness is all wrong. But we can have a look. But I think that's working just by the voltage I was seeing in this area. And then I bet these are gamma as well. Yeah. GG, RG, I'm not sure about those. RG. Sound like red and green, but I don't think they're not. I'm sure this is to do with gamma voltages. Okay. So I suspect that the problem isn't here, and I know that these chips, although I suspect they probably could give you no image, I don't think that's the case in this case. But anyway, let's see what it is. Where's my torch? RT9965. RT9965. Let's make a note of that one. Probably a Realtek chip, that. RT9, what was it? 9965. Okay. 9965. And I think that's the gamma. I see. Just writing that down, gamma. Okay. The other chip is this one, and I suspect this one's got more to do with generating the image. Wise View, DME 5209, I think that is. Focus on him, yeah. Look down the microscope to be sure, because that'll give me a better view of it. DME 5202 N1P. DME 5202. DME 5202. Okay. DME 5202, and then it has some letters after that, which may be irrelevant. N1P. Okay. Okay, so let's have a look and see if we can find any information on these. But we might be able to have a look at the signals and compare the two, and see if we see anything useful here. Okay, let's go over to the screen capture. I hope the screen capture is now working better. I have changed the settings on this. I hope it's working better than it was before. Let's have a look at these two chips. So, data sheet, RT, what is it, 9965. See if we find anything about this. This is the one I think is working anyway. Okay, we have a data sheet, hopefully. Sometimes it tells you that, then you don't. And it's done the same. No data. I hate it when you're doing a search for something, when it can't find what you want. Why does it then give you a lot of the stuff that you're not really interested in, if you know what I mean? Let's try a few other sites. Power management chip for SS. Yeah, this is a thing. Rich Tech. I thought it was going to be Rich Tech. 9965. There's a 9966. No, that's a bit of a shame. Visit site, see if these have a data sheet for it. No, apart from the fact you can buy them. Okay, I'm not going to spend much more time trying to find this one, because I do suspect that this chip is actually working. We can just try a couple other ones. I don't think it's a Maxim. Maxim's a company. There's a link here to a data sheet. No, unfortunately I can't see a data sheet link there. Go on, let's give it one more go, or two-way, but no, we've been to that one. We've been there. Says there's data sheet PDF here, but is there? $9965. No, I don't think we're going to find a data sheet for this chip, but as I say, I do believe that's working. Maybe we'll get to look at gamma IC faults, so we have some more monitoring with a faulty one. You'll see what I'm saying. Normally what happens is the voltage should be like in an ascending sequence, and one is way out, and usually like a very bad contrast picture or something like that, but you do get a picture. Let's look at the other one. Don't hold out much hope for this one either, to be quite honest. GME 5202 data sheet. I'm much more interested to see if this has a nope. Let's just try 5202. See if this is anything. No, it doesn't look like it. Nope. Let's see if I just get the manufacturer from this. It's actually had a manufacturer's name on the chip itself. That might help us. Now let's just go back over to the microscope again and hope it hasn't frozen. Yeah, here we are. It has frozen. It has frozen. I'm going to look down the lenses and tell you what the manufacturer of this thing is. It's a Parade. Oh, it's got another number on it. Parade DP619. Let's look that one up. Parade DP619. See if that one helps us at all. DP61932. Sheet. Was that going to get us anything? Nope, once again it has like similar numbers but not what we're looking for. Let's have that make Parade. Here's something similar. DP621. Parade Technologies. Don't you just hate it when you can't just click on something you want? For heaven's sake. Why? I just want to look it up. DP619. I think this is the wrong chip. Let's have a look. No, takes you back to the page. We're going round in circles, guys. We're going round in circles here and not finding anything of any much use to us. I will ask on one or two of the forums just to see if anybody has a data sheet for this chip, and we'll come back to this if I can find some data. Otherwise, unfortunately, I don't think there's a lot we can do with this. If we can't find the data on that chip, we can't really pursue the repair any further. That's a bit unfortunate, but this is what happens sometimes. So yeah, another failure for now, but if I can get some data on the chip, possibly I could fix it. I mean, it's a bit of a pointless repair. The screen isn't worth that much. I just want to see if I can prove myself better than the other guy was. Okay, no worries, guys. See you now. Bye. So yeah, data sheets weren't really forthcoming. That hasn't helped us any. It's a funny thing, this. It seems to me like all the voltages are there, they're present on the board, like everything's there, but it just isn't working. And I'm wondering if this is something like when we were looking at graphics cards where we had GPU that effectively was reporting back to the computer when it tried to detect it in the PCIe. So we've seen that part of the GPU circuit's powered up at standby, has power all the time, and it sends a reply back to the computer to say there's a card here. And it also has a BIOS chip on there as well, which I'd imagine contains data about the card. And I'm wondering if this is a kind of a similar thing. I mean, I couldn't do it on camera, but I've had a good look down this connector where the jewel's loop, because it's not easy to show you on camera. And the connector looks fine. We know the cable has got, you know, data coming in because we connect the screen and it does give a picture, albeit with lines on. I'm wondering if the other one isn't, like, effectively isn't responding. So there's a few more chips here, a couple here, there's another one here, there's a few over here. I think this one at the end you can't see. This one at the end here, and the fact there's a buck regulator coil here, that's probably a controller, and this will be powering the LED backlight. So I think all the stuff around here is to do with LED backlighting. This one we know, or at least I know, I'm telling you, is to do with gamma correction, to do with these resistors here. In fact, I'll make a note of all these resistors because they're numbered, And I reckon if I put the voltage against each pin in the same order of the numbers here, so like GR01, GR02 and so on and up, I reckon what we'll get is an absolute ascending list from the lowest to the highest, or highest to lowest, on those voltages, and that'll tell us the gamma chip's okay. But also, to be honest, the voltage on both screens are the same, and the gamma's working because you get the picture. So I honestly think that's working. I could make that list just out of interest, but it would just be for interest. This, you can see on here, I mean, if you look at the tracks coming from here, these tracks are all going from here up towards this connector here, which is powering to the screen. And I'm pretty confident that, yeah, there's some here as well. I'm off the screen here. There's another, you can see data tracks going up here as well, and there's like a load of through holes here which go to the other side. Can we turn this over? No, not. I'll have to disconnect the LED screen. We could do. And I reckon they go on the other side of the board and all back to here. So I'm sure this is what's driving these ribbons. Then we have the chip on flex, which we mentioned actually on the ribbon itself. So I think we should have a look. There's a chip here and some here off the board. So let's have a look at some of these and see if we can find something that's. I'm looking for an Eprom, to be honest. That like kind of has like the parameters for this device. So let's get the microscope and let's see what we have. I'll start with the two by this first because they're nearest to that, and I suspect that's what's actually effectively talking back to the PC. Okay, let's go to the microscope cam. Let's have a look. Okay, yeah, we are. So this is the chip, which, where's my torch? Let's get a torch. This is the chip. It says Wise View and Parade, and I'm sure you can see now quite clearly all these tracks go off up here, yeah. And then if I move across, there's another load here. Here, which are probably like the other end, you know, on the other side of the board. Those tracks going over there as well. We're sure they're sending data up to there. These ST, that's the make. 43 to focus that a little bit. 432 EP, 432 WP. Okay, just sort of the focus actually on the camera itself. Let's have a quick look. No, it's because this is raised. The board's raised up, you know, on the laptop, so it's too close to the microscope. But anyway, 432 WP and 402 WP. Let's have a look, see if we can find those. See if that gives us any idea. So let's go over to the screen and let's see what we can see. Datasheet. ST is the make. I'll put that in. I'll leave that. If I can't find it, I'll put it in. 432 WP. What's that? 432 WP datasheet. 432. Once again, all datasheet hasn't found it. It's just giving me a match like. Oh, ST Microelectronics, that's the maker. Ah, this is probably it. Looks like it's an EEPROM or a RAM. Is that going to take us straight to the data sheet? Okay, let's go to the data sheet directly. Why is it now not what to do it? It popped up once it disappeared. I've probably left the little requester open there in the background somewhere. Let's see what we've got. No? How bizarre. Double click. That's strange. That link seemed to work the first time I clicked on it, and then now it doesn't. Which we obviously the browser's still working. We'll go to the ST Electronics. stuck. Says it's an EPROM. That's what I was looking for. Try another link. No, 432WP. Nothing there from ST, so no, it's not that one. I think ST is SGS Thompson, so we can probably correct me if I'm wrong there. Ah, no, it works. Don't ask me, I have no idea. I won't save it, let's just open it, let's have a look at it. There we go. So, I2C, IIC. This is a two-wire bus, clock and data, that's for integrated circuits on a circuit board to talk to each other. I know that even from the 1990s, it's been around a lot. That's what that is. Speed, memory array, page. It's a RAM. Or no, it's electrically erasable programmable reader memory. It's a PROM. EPROM is a memory. I suspect this is, because it's EE, electrically erasable, this is probably something for storing like data, kind of like a RAM, like a static RAM. Okay, what's the other one? 402. 40, somewhere in search there. Can we find an ST one again? Tile data sheet's what it says. This wouldn't find the other one. Nope, doesn't find it. Oh, interesting. Look, it's saying here MC240W. Yeah, like 402WP, but the full number of it. See if that's it. If it says 402WP, right. It's an EPROM. Oh, and we might even have a PDF this time. It looks like it. It's made by ST Microelectronics. This should be the thing. What's that? EPROM. Automotive 2 kilobyte EPROM. 2 kilobit. That's yeah, EPROM. I think one of either of these is kind of like a BIOS, you know. And I'm wondering if that's possibly where the problem is, if they're corrupted or something. Not quite sure how that would happen, but I think what I'll do is let's just get back to the other camera, and I think what I'll do, where are we? Yeah, you can even see me. So I think what I'll do is I'll put the screen on the gives a picture, but it's got lines on, and I'm going to put the hard drive in the laptop. I know it works with an external VGA monitor, so I'm going to connect a VGA monitor, power it up into Windows, and have a look to see if Windows detects both screens. Yeah, and then I'm going to do the same thing with the other screen, the one that is just blank. So I have a suspicion now, I could be proved wrong, that the computer isn't detecting that screen, but it's detecting this one. And if that's the case, and we know the connector looks alright, and all the voltages look alright, I'm down to maybe one of these EPROMs corrupted, or the chip which I buy it, which I'm sure generates the video, maybe that. And although I can't find a data sheet, what I could try doing is taking these EPROMs off the board, and off the other board, and swap them over. Or while I'm at it, I might just stick them on my EPROM program, just see if I can read them, if I can read these. I don't know if it's compatible with this model, and just have a look if they're different, or maybe, as I say, we'll just swap them from one to the other. And if that doesn't help, I think I'll do the same with the big chip, the one that was obviously generated in the video. In fact, actually, I might do the big chip first, because those EPROMs will be contain data, and it's possible that's specific to each screen. Like with a hard drive, if you swap a control board, you have to take the EPROM off the old board, otherwise it won't work. Okay, so let's go and put the hard drive in. Let's go into Windows and let's see what happens. Does it detect both screens, or does it just detect one of them? Okay, back in a moment. Okay, so I've connected a monitor, which you can see. over here. I'm sure on one of my cameras, yeah, you can see it over there. So I've connected the external monitor, and I've got the internal screen connected up, and the laptop's quite happy that there's two displays here. So it's certainly detecting both. I think this might even tell us something a little bit about it. Yep, display information. So there are, yep, there's two screens, internal and the monitor. Okay, so but we know this screen works anyway, apart from this flickering on the bottom of the screen. So what I'm going to do is now is I'll change the screen for the other one that's just giving like a backlight and no picture, and we'll try the same with that one and see what that does. So just give me a minute or two while I restart the computer, and I'll see you in a moment. Okay, and this is the second one. So you can see the screen itself basically doesn't work on this, and it looks though like the computer actually knows it's there. I'm still seeing two displays. Let's have a look. Advanced display settings. I honestly suspected that it wouldn't be able to see it was there. Yeah, it knows it's there. So yeah, I mean that pretty much tells me that the display, however the mechanism to detect the display is detecting it. Okay, so that's interesting. Very interesting. So maybe we're down to changing that chip that looks like it handles the video, and see whether that gets us anywhere on this one. Okay guys, I'll see you after we've shut this Windows down, and we'll carry on with this one. Hi guys. Strange flashing cameras again. Okay, so yeah, we're back with the laptop screen. Since yesterday, I went and asked on this Bad Caps forum, because they have a lot of laptop guys on there. I said I don't really much fix laptops, so I don't know everything there is to know about these, quite truthfully. So I asked about the problem on this, but I was more interested in what these signals here are, these DPRX, ON, OP and so on, and asked if there was a pin out for the LVDS connector. This guy, Pierre, came back to me. He said, Rich, that isn't a LVDS, that's an EDP connector, which supersedes LVDS. He says, and basically, the two that are marked AUGs, yeah, P and N is positive and negative, if you like, AUGs plus, AUGs negative. So it's a differential signal. One end goes up, another one goes down at the same time. This is like this effectively counter interference coming down the cable. So the signal that the chip receives is the difference between these two. And if you get a spike on both, then the difference between the two will still be the same. They'll both have a spike on. That's the idea of differential signals. LVDS is actually a low voltage differential signal. But this EDP effectively uses less wires. And he says that these two, the AUGs channel, he says that is used for identifying the panel back to the video source. In this case, the motherboard. He said, in these ones here, X, there is X0, not I thought it was XO. X0N and X0P, positive and negative again. He says this is the data channel, this is where the video comes in. He says on the high resolution screen you might have DPRX1 P and N, DPRX2 P and N. It has up to 4 channels. A bit like a PCIe slot has four lanes, they call them. This has up to 4 lanes, but because it's only a fairly low resolution screen, it only needs the 1 lane. And so these two are your data, video data. These two send back like the information from the screen, you know, resolution, whatever. So we know the computer detects both screens. So I think we can assume that the AUGs channel, AUGs lane, is working fine. So there's either a problem on this lane, the video lane, or there's a problem with the chip. The two EPROMs I was interested in, the information is that these EPROMs effectively hold what's called EDID, Extended Display Information, information data, which basically hold the data about this screen, about the resolution, and how many colours, the make, the model. So it would again suggest that they're okay because the information is going back to the computer on that AUGs channel. So what I thought I'd do is have a quick look at this EDP, and see what information we can find, if it gives any other useful information. So if we go over to the screen, let's have a quick look at EDP. Okay, so here we are. EDP screen, paying that EDP screen. So some information about EDP screens, the difference between EDP, laptop screen signaling interface. There's a lot of information here. So yeah, this tells us about LVDS and EDP, and it basically tells us the difference between the two. So that gives us some useful information about it. But I did spot, I looked at this earlier, and it says that EDP port was developed by VESA, Video Electronic Standards Association. And if we click on this, this tells us about it, DisplayPort, EDP. And it gives us a bit of information. It's just not too long a document. It's saying it's a new interface for internal display panels replacing LVDS. This is what the guys told me. Mentions the resolutions it can handle. And it's like an advertising thing. That's why to use this, you know. But I'm sure it has some more useful information. So, overview. So basically, this is telling us how it effectively works, yeah? And I did spot it earlier, maybe it was a little bit further down. Yeah, this thing. This is what we were talking about. So effectively, you have auxiliary channel. That's the AUX that we can see. This is what sends the data from the screen back to the PC. In fact, it seems to be sending data both ways, that one, yeah? And then we have these 4 lanes. The main link, and ours only has lane 0. So that is basically telling us more about it, the speed. Again. So you can have a read through this document. It was quite interesting. But one thing it did mention, as I was reading through it, this is another one. Yeah, AUX, you can see. HPD is adapter detect. I think that detects the screens there. Maybe it's HPD that actually tells it's there rather than this AUX channel. I thought it was the AUX channel that probably the HPD tells you the computer it's there, and then the AUX channel gives you the information about what the resolution are, what the settings are. Again, it shows us more of it again, and then we just have 1 lane, yeah? And I did notice while I was reading through this earlier, if I can just spot it now, that basically it's saying that it has a system whereby it only sends video data if something on the image is changed. So if you're looking like on a laptop, for instance, most of the screen is fairly static, yeah? And during that time, it's not actually sending any data to the screen. It's only sending data to the screen when the display is changed. So basically, what it told me in here is that if, for example, when you're playing video, for instance, it's continually sending data to the screen, yeah? In the situation where you're just browsing the web page and it's mainly static, you're reading around, it doesn't send data. It only sends some more video data when you scroll the page, and that minimises the amount of data it sends to the screen. So what I thought we could do with this is, given that information there, I'm sure you can read vesa.org if you want to go and read this. It was quite interesting. But given the fact that we know it only sends data to the screen while video is playing, I'm going to put the old screen back on here, play some video, and see if I can actually see that data coming in to the chip, yeah, the display chip. I'm going to do the same on the bad screen. If we've got data coming into the display chip on both the good and the bad screen, I'm going to change that display chip. If that doesn't help, I'm going to change them EPROMs. So let's go back over to the microscope, which didn't freeze. That's very good. So you can see this is where we have the coming in, yeah, and we're interested in this 0 plus and 0 negative, 0N, 0P rather. We're pretty sure the AUX channel works because the computer identifies it. And these here refer to these up here, yeah? So you've got 1, 2, 3, 4. So 1, 2, 3, 4. 3 and 4 are the ones I'm interested in. And I'd imagine that these would go somewhere to this chip. So see if we've got a good focus on that for you. Any better than that? No, I think that was about it. Okay. Yeah. So first of all, I'm going to get the multimeter. Let's stick it in front of the camera, shall we? Why not? You can see the multimeter instead of looking at me. Yeah, oh, that's good, isn't it? See if it'll balance there, eh? So I'm going to have a look first from the first one of these and see if it goes to this chip. Meter's working, yeah, okay. Let's have a look if that goes to this chip. I imagine it goes to somewhere on here. No. 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 I slipped off that one. Must come down here somewhere. No. Doesn't go to that chip. How about the other one? No. Slipped off it. Try again. No. Okay. Where does it go then? So we can see the two pads come down here. Just go somewhere behind the board. It looks like it comes to this bottom edge somewhere. So maybe it goes to one of these resistors or something. Let's have another look. So on the first one. So it goes down here. Oh. Somewhere here. Unless that was like... Ah. It goes there. So just want to go to another one of these capacitors. Yeah. Yeah, it goes to these two capacitors here. And then from those two capacitors, it looks like, I'll bet the other side of these does go to this chip. Somewhere, can't quite see where, I think it goes on here somewhere. Yeah, it looks like it's going here. No? It is, yeah. Looked like it was going there. One goes there, and the other one probably goes to the next pin. Yeah, so the signal goes in. In fact, you can see the tracks now coming from these capacitors. The signal comes in here on the chip, and this obviously handles the video and sends it out here somewhere, because if you follow all these tracks here, they go off in the direction of the panel. Yeah. So what we're going to do is we're going to connect this screen on, the one that kind of works. I can see it on the monitor. I'm going to play a video, and then I'm going to come down here with the oscilloscope and see if I can see a signal coming in and a signal going out. Yeah. And then I'm going to do the same on the other screen, the one which is blank. If one's got a signal coming in and nothing going out, the blank one, I think we can pretty much say this chip's got a problem. Either that or it is a problem with one of these EPROMs. I think at that point I'll see what's easiest to desolder first, yeah. Okay, so I'll just pause the video, or I'll set up, get the laptop working on the screen, and we can see what happens when we play a video. Okay guys, so I've got a video playing. That's the external monitor connected to the laptop, yeah. And this is my oscilloscope over here. So I'm going to have a look to see if I can see the signals coming in and going out from this chip. I'm not sure I'll see the ones going in because they're probably very small, but let's have a look. I'm getting that much noise on the ground now, if you can see that on the oscilloscope. Oh, the oscilloscope camera's moved. Okay. So if I just want to get this thing to stay still. Yeah, I'm on the very sensitive setting on the scope because I can't see anything much of a signal on these, and I'm just picking up noise. Probably these LVDS signals are extremely small level signals, and I think they're probably going to be very difficult to see if anything's actually on them or not. I mean, there seems to be something moving. It's possible I have a signal there, but it's hard to determine, yeah, because there's so much noise. That's on the ground, yeah. But let's go on the output of this chip. This should be able to tell us. We should be able to at least see driving some data up towards the screen. Let's just go onto one of these pins without the magnifier. Yeah, that's one of the output pins, and you can see there's data on it. Yeah, so the chip is definitely driving data up towards the screen. I don't probe around too much. I've got no magnifier, and I might just end up shorting something if I'm using effectively the naked eye. Can't get a connection onto them now. Okay, so yeah, we can definitely see there's data coming out of this chip. I'll just try and find another one. Yeah, you can see the data pattern. You can see it there on the scope. Yeah, so there's data coming out of that chip. What we need to do is have a look on the other one, the bad one, and see if any data coming out of that. So I should still have a picture on this screen in case I've just shorted something up. I don't think I did. Yeah, picture's still on the screen. Yeah. Okay, so that's the bad one, well, the one that gives the picture, but is effectively got lines on it. So what we'll do is now, so I'll just show you so you can see yourself, yeah, that we do have a picture on that. You see the video playing, like, yeah. Okay, so we'll switch this off and we'll connect the other screen and have a look to see if we can see any data coming out the chip on the other one. Okay, so I've now fitted the other screen to the laptop. Again, we have video playing. I've now managed to balance the other camera on a little tripod, so I've actually got my overhead magnifier free. So I can probably probe this one a little bit easier. So let's have a look first, same as we did with the other one. Just find the oscilloscope probe. There it is. Okay, so it seems to be on these input ones. You can't see a lot because the signal is so small. I'm on 200 millivolts. I'm just picking up a lot of interference basically. Even if I connect to the ground on the laptop with the oscilloscope probe, I've got the same on the screen. Yeah, so I can't really say I can see the data coming in, but again we can check for data coming out. Okay, so I've now got the bench magnifier, so I can actually see what I'm doing without shorting anything out. This might not help you, but it'll help me to get the oscilloscope probe on and hold it on there. Okay, so let's have a look at one of the outputs. Yeah, there's one. And you can see I've just got the same noise on that, whereas on the other chip, I actually had data coming out. Oh, there's data there. You know, this screen seems to basically have the same as the other one. Yeah, I mean, I can't say the data's good or bad, but I can definitely say I've got data coming out of this the same as I had on the other one. I think the next thing is going to be to just change. I'm going to see if I can change both this large chip and the EPROMs from both. So I'm going to swap over these two EPROMs and this on both and see if that will actually give me some indication, because everything I've tested so far basically says it's working and it ain't. Okay guys, let's try that and let's see what happens. Okay guys, so let's see if we can take the chips off this screen and put them onto the other one. It's very strange that I can't see any difference, but for some reason one has a picture and one doesn't have a picture. Unless there's actually something wrong with the screen panel, which seems a bit odd to me. So I think this, although it was very thin, I think this is really a normal PCB. Just happens to be thin. I hope it's not going to melt when I get some hot air on it. So yeah, I've changed capacitors on these types of thin PCBs before. Now I've never tried to change anything big, but yeah, there's a first time for everything. Okay, so yeah, let's see if we can do this. Let's see how well it's going to work. So I'm going to get my old satellite receiver lit, and what I'm going to do is I'm going to balance the screen onto something so I can get this like this. Yeah. So I'm going to try and find something about the same height as that cardboard box, probably. a little bit higher, but it's close enough. Okay. So we're going to do something like that with it. Actually, that's quite nice because these ribbons are hanging down onto here. I want to see if I can, as much as possible, not get too much heat into this ribbon. Because I don't know, I mean, that's held on by heat basically, the tab bond. I'm not sure, in all honesty, which is going to melt first, but just focus on it. Actually, let's zoom in a bit now. Let's come and have a look what we're doing. Focus set. I'll stop making you feel seasick. Yeah, there you go. You have some focus now. Okay, so yeah, try and desolder these without getting too much heat into that. That's the trick here, I think. I'm thinking of using my heatsink. You've seen this before, I think, on some other videos. I use it on GPUs, and I'm wondering if I can actually, if this will work, if I can actually get. No, it's not going to work. I was hoping I could get the pad onto here and effectively use it as a heatsink, but I'd say that's not going to work. Unfortunately, it might, but I don't think that's going to conduct much heat out of that, to be quite honest. Not enough to help, but okay, it's better than nothing, I guess. I'm going to add some leaded solder to these and then try to desolder them. The idea being that the leaded solder will melt quicker than the lead free on the other components. Because this is the faulty panel, I'm going to double check, yeah. This is the faulty one. I'm not going to put any tape around the nearby components, and I'm going to see on this one whether or not they actually move during the desoldering process. If they don't, then I won't really have a problem with the other one either. Let's do these two chips first because these are going to be the easy ones. So yes, soldering iron is on. Let it warm up a little bit. Flux, of course. So let's put some flux on these. That bleep, that was the soldering iron just on. A bit of flux on these EPROMs. And I'm going to get some solder on both ends. I don't really care if I bridge them. In fact, if I bridge them, it'll probably come off easier. So I'm not too worried about bridging the legs together at all. I can clean them up afterwards. So I want to use these chips. I want the chips, so I want to put them onto the board. Yeah, blob of solder on there. I think if you've seen some of my other videos, you've seen me use this technique before, and this helps a lot when you're trying to desolder stuff with hot air and not disturb stuff that's nearby. So, as I've mentioned before, this leaded solder will form an alloy with a lead-free solder. That should melt quicker than the lead-free solder, and I should be able to get this chip off quite easily. So, put the quick on. I'm on 450 degrees, so I want to get heat into this fast and try to do it as quick as possible and try to keep the heat out. Whether this technique will work, I don't know. Again, this is I don't want to fix this panel, so if it all goes horribly wrong on this, it might give me some better idea for the other one. But I'm hoping it doesn't all go horribly wrong. Straight away, the little rubber things fell off. Try again. Okay, let's see if this will work or not. I may be better coming in left-handed with the heat on this one and right-handed with the tweezers. So let's get some heat into this area of the board. We should see the leaded solder melt, and when we see that happens, we can remove the chip. One of them blew off the board and the other one's there. Well, it certainly did the job. One of them's back here. And the other one's here. Okay, they got big blobs of solder on them. You can't see them, they're off the screen. Oops, jumped. Okay. There's one of them. And here's the other one. Yeah. We can now try and just clean this solder off with the soldering iron. Is this in the image? Yeah, you can see that, can't you? This is a bit of just well capped on, stuck to the lid. Oops, that's quite warm, that area. That's good. Bit of flux again. Where have I put the flux? Lost it somewhere. Gone under the edge of the screen. So let's see if we can just clean up the pins on these now. This should probably come off quite easily just with a soldering iron. Probably don't need to use solder braid. Let's move this so you can see it. There it is. Like, okay, shouldn't be able to show you this without blocking the view with my head. Okay, clean the end of the iron. Definitely clean the end of the iron. And that should take that off there. Turn it round. The other end looks fairly clean anyway, but let's do it. I think I can see one solder bridge there between the top two pins. Yeah, looks good. So that's one of them. We don't know which way. I didn't make a note which one went where, but we've got the other panel. Flux again, because you can see it's not going to work without flux. Flux. Clean. Turn it round. Come here, little beggar. Come here, you bugger. Clean. Okay, so there's our two Eprom chips. While we're at it, let's see if we can remove this video chip. Put these safe somewhere, the little plastic tubs, so they don't go walkabouts. Yeah, let's get them in here somewhere so they're safe for now. Don't want to be losing those, and don't want to be mixing them up either with the other board. Okay, that's them in there. Well, they came off easy enough, so this all looks fine. Let's use the same technique. Balance the it's like a heat conducting gooey stuff. This is kind of like a heatsink compound, really. Balance that up on there. Heatsink on top of it. I don't know if that's really necessary, but it worked on the other ones, so let's do it again. Yeah, so it's certainly doing no harm. Flux around the chip. Again, we're going to come in with the leaded solder on all the pins, maybe bridge them. We'll certainly try and get some leaded solder on them. This is not easy, this chip. They're very short legs. This is probably like a QFN. I might not be able to do it on this one. If I'm not getting the solder to form a bridge across, at least I'm getting some solder on them. Okay, that's the best I can do with that. We might dislodge some nearby components with this one, if that's the case on the other board. In fact, I'm pretty sure on the other board I will put some caps and tape just to hold everything down, because I think something's going to go missing. In fact, actually, yeah, let's do it on this board, because you never know, we might want to put the other chips back on this. I mean, if we find this doesn't work, well, I suppose that doesn't prove a lot, really. It worked off this one. I mean, the only reason we put the other chips back on this one would be to prove the chips were good and it's something else, yeah? Which may well be the case here. Okay, it's just a bit of tape on these. You like my method of cutting the tape, don't you? Well, somebody tell me how poisonous it is. You're not going to stop me doing it, but you can tell me. You can advise me, and you'll find that I'm stubborn sometimes. I've done it for that many years now. I don't think it's going to hurt me for a few more, you know. Okay. Okay. So that's got some tape over the surrounding bits. Let's see if we can get this big chip off here. Hot air again. With the solder down that way, I'm going to come in right-handed with the heat this time. Go left-handed with the tweezers. Hold the tweezers a bit further up because it's going to get warm. warming. I can see the flux bubbling away underneath it now, and I thought it was melting out. I wonder if it has a big metal tab underneath it, make it very difficult to unsolder. Yeah, it does. So I got enough heat into it, moved it and then lost it again. This is fiddly. That's 3 times I've desoldered it, I can't pick it up. What? Huh. This is right fiddly one. And bear in mind I want this chip. Okay, that's not helping. Let's find a different way to pick this up. That's not going to work, is it? I have a vacuum pickup tool. I've never actually had to use it before. It's the first time for everything, so let's see. I'll get it together and we'll just pause the video. I'll get the thing together and then we'll try it. Maybe if I try use the right hand with the tweezers, because this has been a right slippery little beggar. Must have dropped it about 4 times. It's very difficult to get under the edge of it. Let's see if we can lift it this time. I'll try to actually get the edge of the tweezers underneath it, I think. Yeah, it's moving now. No. I'll have it in a minute. Yeah, I've got it. Look. What a mess. Oh, what a mess. Let's see how much mess we made of that, eh? Let that cool down a bit. This is definitely absorbing heat from the tab bond, so that's obviously doing its job. We have a chip. I hope it survived. Still very hot at the moment. I'll pause the camera while that cools down and then we'll have a look. Okay, that's cool enough to touch now. Let's see what we have. Got all this Captain tape. Yeah, I think that tab bond survived. That was one of the things I was worried about. Okay. For all that mess, I don't think I actually dislodged any other components. Maybe something here. Yeah, moved one here. Let's have a nosy under the microscope anyway, just out of interest to see how that looks. Let's go over to the microscope cam. Let's hope it hasn't frozen, eh? It's frozen. Let me just restart it one moment. Okay, camera's back on. Let's have a look at this thing under a microscope. Not as it matters, this is the one that had the lines on the screen. I'm just interested to see how that works out, because obviously we've got to do the same again on the other one in a minute. And that one's rather more important. Where is this circuit board? Move the microscope a bit further over so we can get at it. Okay, yeah. Looks like I can dislodge something. Not surprised considering the problem I had lifting that up and moving it around. Okay, so we have to be very careful with the other one, removing the chip. I'm not really sure how, but yeah, at least we know what went wrong this time. Okay, let's try and remove the chips off the other one. I'll put these ones safe on one side. The chip, by the way, came off nice and clean after several attempts, because I couldn't get a grip on it. There it is. I do have a vacuum pickup tool, but I can't find the end to it at the moment. Okay, hold on. Okay, so this other one, I've just removed those 2 chips because they came off really easy compared with the other. Well, the other one was easy enough. These came off very easily. compared to that big square chip that was a right pain. Let's find a bit of solder braid, and I'll just clean these blobs of solder off here, you know, where I basically bridged all the pins together, as you've seen me do several times now. We'll clean this up and down. Let's have a go at this square chip. This time I'm not going to put the captain tape all around this. I actually think, although the intention was to protect the nearby components, I think it actually made the job a lot harder for me. So I'm going to try without. I've put some flux around the chip. I'm going to try my best to get leaded solder down on all the pins. But to be quite honest, because this thing has a large pad directly underneath it, almost the size of the chip, this probably isn't going to have any help really. Probably isn't going to have any effect at all doing this. But anyway, we can see. So there's a blob of solder on the end of the iron. That's as best I can do. So hopefully a little bit more flux. The flux is going to run underneath this and maybe help to desolder it. And I'm going to try this time to pick it up without the captain tape. So this will either work much better or make a right pig's ear of it. Let's have a look, see what we can do with this one. I'll keep the heat away from the screen as best I can. Just warm the general area a bit first, and then we'll come in close and try to remove this chip. The problem with it basically, it's very slippery, so when it does, the solder does melt, it's very difficult to pick the thing up. This is the problem I had last time. Looks like it's getting ready. All the solder flux has gone underneath, all the flux has disappeared underneath. Now I have it. This is the probably faulty one anyway, so I'm not too worried about this. Can I pick it up? Not like this. And now I'm running into the nearby components, what I do not want to do. I'll try come in with the other hand, see if I can get the thing to lift, if I can actually get underneath it. Yeah, I got it. Okay, let that cool down and see what I've dislodged. It'll be clearer under the microscope, but I think maybe I've just dislodged something here or got a bit of crap on it. Everything else seems to be okay. Okay, let's just pause that while the whole thing cools down enough to handle it. Okay, so we're under the microscope, it's cooled down enough to touch now. Let's see what mess we made with this one. This doesn't look too bad. We'll just clean this up. This is where the EPROMs were. So first we'll just clean this area up. We'll get a bit of braid again. Cut the end off the braid so it's got a nice clean end on his cutters. Okay. Let's just clean up the pads off these EPROMs. Okay, so first one here. I'm really looking down the microscope, it's easier for me. That very nice and clean. Let's go for the other side. They're certainly nice and clean. Come back on these a moment, a bit more flux on the end of it. Yep, they're looking good. Just go for these ones. Yep, they're nice. They're nice. These ones are still a bit messy. Let's just redo them. Yeah, they're good. Okay, that's all nicely cleaned up. So replacing the EPROMs with the ones from the other board, that shouldn't be a problem. Let's have a look to see what's happened with the big chip that we removed. Okay, so this is the chip, and yeah, we can see straight away what I've managed to do is to dislodge a couple of capacitors here. They're probably stuck again now. And that one's actually come off. This is when the thing slid backwards and I was trying to lift it up. That one's in place. This is not really a problem. I mean, first of all, we've got both the capacitors. Secondly, they're almost certainly the same value as each other. And thirdly, we can always take the ones off the other board. So I'm really not too worried about that. Everything else seems to be in place. I looked on the other board because I thought I'd dislodged. You know, I had a resistor over here somewhere, here, and I thought they'd come from there. But this board already had nothing there the same, so nothing's missing from there. Everything else looks good. Yeah, so let's clean up this chip now. But everything's looking promising. The board looks good. Flux around this one on the pad, and once again in with the solder braid. I'm still using this quite narrow solder braid for this board because everything's a little bit small. If I don't have a lot of luck, I could try the thick stuff I use for the BGAs, but I think this is going to be fine actually for this screen, for this board. So okay, let's just get in here first and start to clean these. They look nice. They look nice. I'm going to cut a little bit of braid off the ends actually, and I'm going to just kind of like drift it over the board. That'll probably be a bit easier because I don't have heat go up the braid. Although this braid being thinner than the other stuff I use for the BGAs, that's not normally such a problem with heat being sunk back up into the braid. Let's see if this will work. The thick stuff definitely have to cut a little chunk because otherwise it won't work. Yeah, that was working. That's nice. Look at that. See, should have done that in the first place, but it's so much easier. Come off the pad. I want to do the legs first. We'll come to the pad in a minute. That's all the pins cleaned up now. Let's see if we can just clean up this pad a little bit. It looks pretty good anyway. Braid stuck to it. Get some heat here, little bugger. Okay. That was good. That was clean. We can get a bit of the isopropyl alcohol on that, and that'll just clean it all up for us and we can have a good look. Sorry, forgot to restart the microscope recording. Yep, we're on. Good. As you can see, I just started to clean this up a little bit. That's a good job, that is. That's nice. Okay, that's come out nice and clean. So we need to add some leaded solder to this. It's going to be much easier to resolder with the hot air if we use leaded solder because the temperature required to be so much lower, and we should be able to do this quite easily now without even melting the solder on nearby components, which is lead free. So let's use the temperature difference to our advantage. So we'll get some flux on and we're going to get some leaded solder on this, and then we'll use braid again to clean it up afterwards. But first of all, let's get some leaded solder. Unless it's looking good, we might just leave it on there, but I probably will have to just get it sort of flat again. Okay. So now we come in with some leaded solder. I'll use the thicker roll. I think it'll be easier. There it is. I think it's going to be easier to use the thicker roll for doing this with. So basically I want to add leaded solder to everything under here. all these legs not ready to solder on them. I'm now ending up with rather a lot in the middle, but we can get that off afterwards, that's not a problem. And every single leg, every single pinny, every single pad, leg on every single pad, so I've ready to solder on it. Okay. I've just knocked another capacitor off, I might have done. Not a problem, we can replace them. Okay, what we need to do now is to clean out that big blob we've got in the middle. So I will use some of the thicker braid for this. For this thicker braid in the middle of there. Yeah, nice big piece, probably a bit too big actually. Let's make that a bit smaller. Here we go. Microscope's frozen. How long's that been frozen for? I really don't know. This microscope's just hopeless this afternoon. I'm definitely have to get a different lead on that, see if it'll fix the problem for good. Bit of focus. So I may have dislodged another capacitor while I was just getting some good solder onto this thing, but still not a problem. Let's have a look down at some microscope and let's just melt the stuff I've got in the middle. I've got quite a lot of solder in the middle of this now, more than I want. Okay, that's good. There's the tweezers. Just keep it hot enough to melt and get it off the board. Okay. There. That looks good. Okay. Clean it up. We probably have to remove this bit, and this, the knack of this is to get this flat, certainly so it's not raised above these legs, otherwise it won't be solder. I think we took a capacitor off there. Let's say we can replace these off the other board, it's not an issue. The main thing is going to be getting this chip replaced. Yeah, I still have to take some solder off that centre. So once again, we'll take a bit of the thick braid. I'll do this without my glasses, probably. Bit of thick braid. This alcohol's not a problem. It'll just kind of evaporate when I put the heat on. That's not a worry. Put that on there. Put some flux onto it. Well, I might have got some flux there as well. And once again, I want to just clean up this centre pad. If it's raised too much, it'll kind of hold the chip slightly off the board, and then you won't be able to get it to sit on the legs. You won't get it to solder. That's the problem here. So again, notice that alcohol didn't have any effect. It's not a problem. Got enough heat in to move it. I'll probably want the tweezers again to lift this off the board. Got this stuck. A little bit more flux. A little bit of solder on the end of the tip. And we'll unstick it. Solder. And we'll soon unstick this thing. Go to the edge of it. Get in there. That should be unstuck now, yeah. I'll just keep the heat on for that a moment. Get a good grip. Okay, off we go. That was flat. That was a lot flatter, that's what I wanted. Again, we'll come in and give that a clean. maybe put just sort of spot in the middle now. I want to try and get a bit of solder on, but not so much that it actually raises up more than the pads. But I need to get a little bit so that when we solder this back on, that'll kind of spread underneath it, yeah? It doesn't need to be completely under all of it, but use the thinner solder in fact, so we get a more controlled amount of solder on it. That'll probably help a lot. Yeah, that should do. The whole pad doesn't have to be stuck down, just as long as some of it's stuck down, then the heat will transfer into there. Although I doubt there isn't that much heat comes out of these chips, to be honest. But yeah, it needs to be, you know, it was there for a reason. It needs to be stuck down. Okay. So this is ready now to start resoldering the chips off the other board. We'll put the big one on first, that's the more difficult. Then we'll put the two EPROMs on, and then we'll come back and fix these few components that seem to have gone slightly AWOL while we were doing that. And then we can try it. Fingers crossed, all this effort is actually going to work. As I see. I think that's pretty good, to be honest. Some pins seem slightly raised to others, but I don't think it's going to be a problem. I think that will solder. Okay, let's get ready to solder it back on. Okay, so I've got the large chip back in place on the board. It may be possible to solder this, you know, with a soldering iron now, because there's like small legs around the edge of it. The technique here would be to kind of get it lined up and just tag one of the pins in one corner, then make sure it's lined and tag pins in the opposite corner. Once you've got the two corners down, you can then sort of run around the chip and solder it, basically. One moment. Sorry about that, somebody at the door. Camera didn't freeze in the meantime. Okay, so yeah, I'm thinking we might be able to solder this just using the soldering iron. I've got some of the thin solder. I've got the VC3 tip on, the big chunky one. Let's have a look down this microscope and see what we can do with it. So first of all, the knack is to get the thing to line up. That's fairly close. I don't think it's exactly, but it's fairly close. Let me find the other tweezers here I've got. I'd actually say that's pretty much spot on. I'll move this a little bit. Doesn't matter getting all four sides in line. The hair there or something. Don't want that. Bit of hair or something. Whatever it is, we don't want it under our chip. Okay. So we get into place. That was good to me. No, it's out again. I think what I'll do is I'm going to tack down one corner. Once I'm happy with it being in place. No, you see it's too far out that way now. Probably a bit of sticky flux under this going to help actually. Let's get a bit of flux under it because the flux is sticky, and that'll probably help to hold it in place while we get it positioned, and it shouldn't move. I mean the whole board's sticky anyway from flux, to be honest. We know the chips are that way round, as I made a note of it earlier. Oops. Strange, this one always has like a cut off there, and oh yeah, and there's a dot. Yeah, the thing rings true. There's a dot in one corner, and the dot is where that little cutout is. There's a little dot down there. Apart from this big one, there's a small one. Okay. That's actually made it even more slippery. Maybe a bit too much flux under it now. Okay. Once again, let's clean that off. I want to get it so it's all nice and sticky, basically. There's still flux under the chip. That's okay. So I'll kind of like stick back down again. It's a bit scratched off the tweezers, but that's not going to be any sort of problem. so I'll just move that. I thought I had it just in position there, a little bit moved. So if we get one pin soldered down at the end, that's going to help to hold it in place while we finish the job. Okay, submit it up. Okay, so we've got the chip in place now, and it's kind of, I've just tried to tag a couple bits of solder on the various corners to hold it in place, yeah, and tap that it's not moving. So I can see the legs are lined up, or nearest damn it lined up with the pads. So I think now it's going to be a matter of going around this chip with some flux and some solder, and let's see if we can actually get it into place. Probably afterwards I'll probably get the hot air on it just to make sure I've got a good solder joint all the way around it. But if we solder it in place first, then the tension of the solder should keep it still while the hot air finishes the job. And of course I can't solder the centre pad underneath this way either, so I will need to use the hot air on this afterwards. The idea being that there's having leaded solder on now, the melting point is lower than the lead free, of course. How many times have I said that? Too many. Drag a bit of solder on here. I'm not too worried if I've got any solder bridges, I can soon get rid of those. That's not really a problem. Like for instance I have one there. Just drag the tip away, we'll probably remove it, otherwise we can always bit of solder braid. Okay, that edge seems really like it might have soldered. Let's come down the side now. Clean that bit of solder off the top of the iron there. A bit of crap on the iron. A bit more crap on the iron. Crap or solder. So I'm just dragging it now down the side of the chip. This side shouldn't be too bad to do. A bit of solder in, just drag it along here, and try to get some onto each of the pins. Okay, bit of flux down this last side. Just turn it around a little bit to make it easier for me, coming from a different angle. Okay. As you've probably seen a lot of these videos now, I'm using this large tip because I can get a lot of heat into the joint. With a small fine tip you wouldn't do it. Okay. That looks not bad actually. Let's clean up the stuff off that, the flux. Where's my little bit of isopropyl? And let's see if that's looking good. If it's looking good, then we can get the hot air in, reflow it, and it should stick down nicely. And then after that, it's basically just a matter of replacing all the EPROMs and the couple of 3 capacitors that we dislodged. And we should have a good job. If there's any pins that don't look like this soldered, I can always come back along and have another go at them. Okay. Let's have a final look to see what we have. if it's good. So. First, we can say for certain it's lined up. It's lined up good. Looks like there's a few pins that didn't take any solder. But I'll try to reflow it first with the hot air. If I'm not happy, I'll come back again, I think, and have a go with the solder. But there's maybe a couple down here. But I'm hoping there's enough solder on underneath to do the job. Remember, there was already some solder on the pads as well. This side probably wants a bit more of a clean to have a good look at it. So turn it round even, see if that helps us. Where is it now? Over here somewhere. A bit further, yeah. Yeah, it looks better from that angle. Okay, I certainly soldered it down. I'm certain there isn't solder on all the pins. So yeah, this top edge, this looks good. That edge looks good to me. Turn around. This one doesn't look quite so good, so let's have another go at that one, I think, before we reflow it. Maybe this will help turning it round to the angle where I can most easily work on it. Okay. Got a solder bridge in here now, but that's not a problem. I think I've just got rid of that. Maybe a little more in this area. A couple of these pins. There's a bit of a blob of solder, a little bridge in here. Just wipe the iron and come back at it. Yeah, there. Okay. So rotate it around again. A few splashes on the screen, but that'll clean off. That's just a bit of flux and isopropyl splashed around. Okay. This side, I've only got a few of them. I was going to reflow it, but then I thought, let's have another bit of a go at this. So again, a bit of solder. These are the pins that don't seem to have any solder on them. I'll just clean the tip, get rid of the solder off the tip, and then we can probably just drag out any solder bridges that we might have caused. Okay, last side again. Things in the way, so I can't actually get the screen where I want under the microscope. Sorry, the board under the microscope. Move a few things around the desk, make a bit of room. Okay. This side. You have to take your time with this, guys. You can't rush these sort of jobs. I'll tell you now, I can't. I mean, I'm sure there's, looking on eBay, there's some fantastic solderers out there, and they're better than me. I can do it, but I'm not a master, like a master of some of these guys are. Either that or they edit the videos, they cheat. either they're fantastic or they cheat a little bit. I'm just doing this as it is, you know. Yeah, they're looking good. Quite happy with those. Okay, let's clean it up one more time and have a look what we have. What we got now. Okay, looks a lot better. There might be an odd pin that isn't soldered. It's certainly lined up. That's a good news. Okay, we're going to reflow that now. Get it under the hot air and so it melts the leaded solder, which won't affect anything else around it. And then now let's see what we got. Okay, guys, see you in a minute. Guys, this is the screen that we fitted the replacement chip on, the video chip. And it looks like I've got solder around pretty much all the pins. I think I might have a solder bridge up here on that first two, and maybe a couple down the bottom edge, maybe one there. They don't have any solder, so I'm going to have a look around this on the microscope, see if I need to put any solder on any more of the pins, and then we will use the hot air and just flow over the whole thing, just let it sort of bed in, and it should solder the tab that's underneath here. Remember, it's a big square tab, and help to flow the solder under the pins as well. So okay, let's get down the microscope and have a look. Yeah, this certainly looks like a solder bridge just here, so we'll try and clean that up first. Get some flux on here. All the rest of this side looks good. There might be another bridge there as well. There might be one there and one up here. The rest of the side looks good. Okay, I'll try first just coming in with the soldering iron and just seeing if that will effectively disappear, just with a clean soldering iron, no solder. Yeah, looks like I've got that one. Let's get down on this as well. That looks like I've got that one as well. In fact, well, let's just touch down this side. Yeah, that looks good. This side, I'm thinking. No, there's one there, and then one at the end by the looks of it. To make life easy for myself, I'm going to turn the screen around, coming from this direction. If I can fit it under the microscope, I'm hitting the base of the stand. Okay. Yeah, a little bit dubious as to whether this one is soldered and the ones at the end. They may be, but we can just get in there and check. Maybe one there as well. For this I'll probably just need a little bit of the 0.2mm solder, nice thin stuff. And let's just see. I want to come in this way up because I don't want to disturb any of these capacitors and resistors here. If I can't, I'll have to come in flat. I think there's one just here maybe. Okay. I think I've still got ones at the end. I mean those are solder bridges there. Okay. That's that side. Let's go around for side 3 and let's have a look to see what we have on this one. Where is it gone? Okay. That one looks pretty good to me. Possibly that bottom leg. I've got a little bit of solder on the test point down here. That's not going to be a problem for any reason. solder out of the way. Oh yeah, okay. Yes, I've got a little bit on that test point. This pin here may just need a bit of soldering. Again, we'll need a bit of flux here. The rest of the side really looks good, and this top, this looks good as well. So let's just get into this one and see a little spot of solder on the iron, very small amount. Okay. Alright, let's clean that up and let's see if we now have a good looking chip, and then so say we will just reflow it. We'll get the EPROMs back on afterwards. We'll sort out these few little capacitors that have gone AWOL, and then we can try this and see what we have. Okay. Oops. Not the microscope. I'm sorry yesterday, by the way, when I was doing some of the soldering, I was out of view on the microscope. The problem is that my field of view is considerably wider when I'm looking through. So I can see, like down here, I can see the whole chip and you can't see it. So that's why sometimes I'm off the screen. I'll have to learn to be a little bit better at that. Okay, let's have a look. That looks good now. It seems to have a little blob there that we probably just want to deal with, but other than that it seems to be nicely soldered. Just deal with that little blob. Where is it? Here it is. Yeah, there's like a little blob. You can see it there. I need to do something with that. I'll just try first and just get it to. No, I'll put some flux. At the end of the day, everything works better with flux. Get a bit of flux in there, and just get in here and just try to clean up. So I've got no solder on the tip now. I'm just heating that bit. Okay, let's see if that's cleared that up. Okay. Yeah, that looks good. So now we're going to reflow this and just after that fit the EPROMs and the capacitors, and then we'll see if it works. Okay, so we're back on the overhead camera. I've just put the little like rubbery heatsink pad here again onto the ribbon to try to get the heat out of it. It was certainly working before. Balanced the heatsink on top, and I've just got a tissue under the other end where it's resting on the screen so I don't scratch the screen. So I'm just going to warm this up now with the hot air, and visibly we should be able to see when this actually starts to bubble, and we should be able to see the solder melt a little bit. So we shouldn't really need to put a thermocouple on, but I will put the thermocouple. If when you're learning this, it's best to use a thermocouple. I mean, you know, these meters cost, these temperature meters with thermocouples, they're less than £5. I got two for like eight euros or €9 with postage. So you should buy yourself at least two of these. They're extremely useful, and it kind of takes a lot of the guesswork out of this. Yeah, sure, as you get more experience. I mean, I could happily do this without using the thermocouple, to be honest. But for your benefit, I'm going to put it on the board so we can see what it's doing. Just need to position it so the thermocouple actually touches the board, not floating in the air. Okay, so it's touching the board. I'm in the general area of the chip, yeah? Okay, so watch the temperature meter and also watch the chip as well, and you should see, where can we put this? so you can see it. I might end up putting it in the other camera actually. Yeah, hold on, let's just move some cameras around so you can see. Balance this up somewhere. I'll just pause this while I'll just set this up for you. Okay, that should do. No milk, it'll fall over, but who knows. So yeah, there's thermocouples down here near the chip. Heatsink on the ribbon. Hot air is set to 450 on full flow. And hopefully you'll see this reflow. I don't want to get too close yet, I need to just get the area to warm up. It's quite nice, I can actually see that. If I take the heat away, you'll see the real temperature that I've actually got the board up to. I want to get up to about 220. It's hard to do like this because you've got the hot air blowing on, you can't really see. I've just took it away. Yeah, so really it's less than 100. I think probably more visibly I'm going to have to go by what happens with the chip. You see the flux. I'm going to add a little bit more flux to this. There is flux under it, you can see that. But let's add a bit more flux around it. The flux will certainly help. Never does any harm as such. We'll turn the air down a little bit. It's a bit powerful, that is. Don't want to move anything. There we go. Okay, I'm down at about 45%. Can you see that solder starting to go shiny now? So when it gets up to temperature, it will be shiny. Let's get to about 200. Was that the real temperature? Let's just move it away. No, it's not quite up there yet. Let's see. Yeah. Dropping very quick. I'm not sure how much that's dropping because it's sitting on this metal plate. One last go. All the flux is kind of evaporated now, so that means it must be there somewhere. Yeah, I'm pretty sure that's hot enough to actually solder. So we'll let that cool down, and then we'll have a look at it under the microscope again. Okay, so moment of truth, guys. We've done it. Let's switch this on and let's power it up. I've got the external monitor connected again, and let's see what happens. Doesn't look good, does it? Doesn't look good. Let's just fade it back to the blank screen. So I don't think we did any harm to it. I mean, it's the same as before. Some lines appear, then they disappear. It goes kind of like that. I don't know. There's obviously something wrong with this compared with the other one, but as to what? Good question. Are we going to get a picture? Yeah, we probably will get video on the external monitor just to be sure. You can't see that, but I'll show you if it comes on. Don't know. Let's just see if we get a picture on the external monitor. Give it a moment to boot up. Yeah, so it's booting up. Still. So I don't think we damaged anything, we just didn't fix anything. Let's have a look if it still detects the screen. That'd be interesting to know, wouldn't it? This just take a moment to boot up. I'll just pause it because it's a slow machine, really, to be quite honest. Just give it a moment. Okay, it's loaded up now. So yeah, let's see if we can screen properties, and let's have a look, see if it still thinks there's two screens attached here. Display, where's that gone to? Come back. Display settings. Can you see that? I'm not sure how well it's coming out. Display settings. This machine's not quick as it all. The installation of Windows has got a lot of stuff clogging it up. Go on, finish booting up and it'll tell us what we've got. Ah, it woke us up at last. Can we see the display settings now, please? I asked you 5 minutes ago. Come on, please. I think we asked it so long ago we forgot what we wanted it to do. Come on. Huh. Okay. Ah, okay. So it's two screens there. That's fair enough. So we still have two screens. We go to advanced settings. Not advanced scaling settings. I probably want something different than that. Advanced settings. Advanced display settings. Yeah. That's my screen. And that's the internal display. So we didn't break it, but we didn't fix it. Okay, I need to think a bit more about this one, and I'm going to ask one or two people. I've reached the limit of my own direct knowledge here, but let's see if we can find out what's wrong with it, see if we can actually fix it. Okay guys, cheers now. Hi guys, I thought I'd have another look at this laptop screen. I was messing with this last week, trying to get it to work, and basically everything seemed to be okay. You know, like all the voltages were there, sending data to the screen. So I swapped the video chip, I swapped the EPROMs, and it didn't make any difference. And at this point I thought, well, as I said on the video, I can't really see any difference between these two. It should work. So anyway, I asked on the BadCaps forum about it, and one of the guys actually sent me a private message, and he said, actually, Rich, he says that problem you've got there is typical, it's classic of a corrupted EDID EPROM, the EDID EPROM. Oh, and by the way, nice video, keep it up. Like, cheers, man. So anyway, he sent me a file. He said, look, he says this is the actual file for the EPROM. He says, have a look at yours and see if it matches. And I said, okay, yeah, cheers, thanks for that. But I can't understand why in that case it didn't work when I swapped the EPROM from the other screen. And he says, no, I completely agree with you. He says, I can't explain that either. He says, well, give it a go. So I thought, yeah, okay, it's not a big issue. So I've taken the EPROM back off the screen. I originally used the other one, the spare one, and when I tried to read it in the program, I couldn't read it. And I figured out after a little while that the reason I couldn't read it, this is the little adapter, so I've soldered the EPROM. And it says here that it's MSOP, that's the package type, and it goes here. But in the list of devices, I have this device, the correct device, but only TSOP, which is a slightly bigger package, but the same device. And I noticed on this adapter for the EPROM that this EPROM is wired to pins like 5, 6, 7, 8, 9, 10, 11, 12. It's not wired from pin 1. And I'm thinking, well, I've got another adapter for the TSOP, which I always think sounds like the sound of Philadelphia, you know, if you remember the 70s, but it's an IC package, TSOP. And it was wired from pins 1, 2, 3, 4. And I thought, oh, strange, I haven't got the right adapter for that package. You know, I've got the adapter for the other package, but for this package, I'm assuming when you choose the IC, it knows it's on pins 5, 6, 7, 8, and so on. So what I've done is, I thought, I'm going to get out of that. I actually took an 8-pin IC socket and broke it in half. And I've extended the pins 5, 6, 7, 8, so I can now put it into the Eprom programmer for pins 1, 2, 3, 4. Yeah? So I can get that into there. And I'm hoping now it'll read. Before it was just saying FFFF, and when I tried to program it with the guy's file, it just said error. So that's what I've done. So let's have a look to see whether or not we can actually now read the contents of this chip, compare them with the file the guy sent me. And if it's different, let's put his file in. And out of interest, let's see what happened. I've no great expectations, as soon as it didn't work with the other EPROM, but you know, nothing ventured, nothing gained. So let's go over to the screen. Let's have a look. So this is the Eprom programmer. I've already got the right part in. If you remember, it was marked 402WP, and when I looked at the datasheet, it tells me that as a M24C02W, which is what this guy also told me. And he thinks it's a TSOP package. So this is why I've had to sort of frig the thing to make it fit that way. And I'm hoping now I can actually read this EPROM. So let's go to read. It said it read it before, but it was all Fs. Now it's not all Fs, so I'd say that is reading the EPROM, and that's what we have. A little bit of content in there. So let's save this. Save ours. Save. We give the option, yeah. So this is the file he sent me, and I'm going to call ours original, yeah, which is the original one I've read from the chip. So let's save ours. Okay, so I've now got both files. Let's see if they're actually the same. So I've got this Exam Diff Pro. I think this is the one that probably complains it's not licensed and then lets me use it anyway. I use this so rarely. Perhaps if I use it a lot, I should be paying for this. Now I accept, you know, pay for tools if you want to use them. But I use this quite rarely. Okay, so let's see now. I think I called it the file something like lap screen or something like that. Always remember where you put stuff. It's not HP lap. Sorry, excuse me. LCD EPROM. So this is the original file, and we'll select that one. And then here we'll select the other file. You'd think it'd go back to the same folder, wouldn't you? And it doesn't. LCD lap. LCD EPROM. This is the file the guy sent me, and we'll select that, yeah, and we'll tell it to compare them. And it says they're identical, so that's eliminated that possibility. There's no difference in the file, so that doesn't explain why the screen's not working. So on to the next, I guess. I do have one other idea we can try on it, so we can try something else, but it's certainly not this. Okay. Guys, this is our laptop screen that doesn't want to work, and for me now this has become something of a challenge, to be honest. I'm long past caring how long it took me. Either I want to find out why it doesn't work and fix it, or I want to find out why it doesn't work and I can't fix it. And I'm not really bothered now which of those two outcomes it is. The reason being, if I fix it, great, I fixed it. If I can't fix it, at least I want to know why it doesn't work, and that in itself is a good outcome, because I've not looked at trying to fix an LCD panel before, and even if I end up just understanding what's wrong with it, that'll be handy. So as you know, we've had two of these panels. One had a line on the screen, but apart from the lines on the screen, it gave a picture, and this one gives no picture, just the backlight. And we've changed the video chip, we've changed EPROMs, we've went all over the screen before that, and I made a note of all the voltages on all the test points, and I compared them with the other one, and I couldn't see any difference, you know. I mean, basically all the voltages were there, very similar to each other. You know, like there wasn't a case where, like, on one board I got 12 volts, the other one I got like 2 or half a volt. You know, there was nothing glaringly different. They weren't exactly the same, but they were all close enough, I think. And that didn't help us. We then checked this video chip, and we could see there was video going to the screen. We discovered these EPROMs are to do with recognising the screen, and it does recognise the screen, the laptop does, but that, you know, we changed the video chip, we changed the EPROMs, and we still have this grey screen, backlights and no picture. I then, if you watch the last bit of the video, we took the EPROM off, and somebody sent me a file with the correct contents, and even though I'd swapped the EPROM, we thought, okay, let's just check them, and I actually checked both of this EPROM 402WP, which is telling me is the right one. I read the contents, I compared them with this file, and they were the same. So we're still back to this thing, like, what's wrong with it? So in the meantime, while this guy was telling about these EPROMs, somebody else on Bad Caps Forum came back and sort of said, look, Rich, he said, if all the voltages are present for the LCD panel, VGH, VGL, VCOM, blah, blah, then if it still doesn't work and you've got data going to it and it's recognising it, it's the panel itself. There's something wrong with these chips on the flex or something with the panel. So I thought, okay, fair enough. What's VGH and VGL? Because I don't remember seeing any test points that were called anything like that. So as you often find on help forums, people can't tell you often what, you know, change this and it'll work, because you don't know exactly why it doesn't work. They haven't got it in front of them, but they can tell you what you should have there to make it work. And this is what this guy had done. So I thought, okay, fine, let's go and find out what he's talking about, shall we? So I went and had a look. I'll just go to the screen capture. Basically, I went and Googled for what he was asking me, VGH, VGL, VCOM. I do recall seeing VCOM on one of the test points. I thought, oh no, I remember seeing VCOM. So I went to VGH, VGL, VCOM, and I can see straight away LCD, VGH, VGL. These are to do with LCD screens, voltage modules, the voltages. So yeah. And one of the first links I found is this one. This is a website called PCBartists.com. It looks like PCBartists. PCBartists.com. And it's a schematic for generating these voltages we're talking about. Yeah, for a TFT LCD. I'm not sure if mine is a TFT, but maybe it is. So it tells us a bit about the voltages. And it gives us some typical voltages for each one. Yeah, DVD, D, AVDD, VGH, VGL, and VIH, VIL. And it gives us some typical voltages, or minimum, or maximum. So that's okay, that's useful. So this is telling us we need these voltages present for a screen to work. And I know that there's not test points for all these, so perhaps that's what's wrong with it. Then goes on, gives a rather nice schematic. shows a chip that they're using, some little double diode packages, and it's this circuit's generating some of the voltages there. And there it is. DVDD is saying it's 5 volts, and it looks like it generates all the rest from that one. Okay, oh yeah, it's telling you which order they come in, DVDD and VGL, then VGH. So they have to come on in a certain order. Okay, so that tells us about the circuit. So there's a nice burger. KFC. As far as I know, we've only got one KFC on the island, and it's up at Altablero, which is about a 30-minute drive for me. So if I want a KFC, I have to drive 30 minutes, which is rather unfortunate. But there you go. There are some things we don't miss them. We do have them here, but sometimes it's just not as easy as getting here in the UK. Okay, so that gives us some voltages. So I've written these down, the typical values. I want to now see if we can actually find these voltages on our screen. Yeah? Let's see if they are there. So go back to the overhead camera. Right. This is my note of all the voltages, and I did note that AVDD should be 16.4 or thereabouts, and VGL minus 6.9, VGH 16. Well, I know I've got some minus voltages on here there, minus 6.64, so that's probably the VGL, you know, because it's in the region of where it is. But I had a look through all this lot, and I couldn't really see any voltages that are 16 or 10 or in that region. Yeah, there's some higher, 22, 19, but all the rest are like below about 6. Yeah, so I suspect those voltages they're not on these test points, they're here somewhere, apart from maybe VGL as possibly that one. So I have a list here of the voltages we should find. Yeah. Now also, I know this in the past, I've fixed some TVs, that I mentioned this before, an LCD panel needs gamma voltages. And I mentioned, if you've been watching, this chip generates the gamma voltages, and there's test points here, like gamma 1, gamma 2, gamma 3, and so on. And I did mention to you, this is like a ladder, they're like an order, and I said, oh, I'll make a note of them later. I never did. So I've done that now. So this is what you should find on gamma voltages on an LCD panel, whether it's a TV, whether it's a monitor, whatever, is effectively a sequence of voltages that starts low, and look, they're in order, 11, 12, 9, 8, 7, yeah, and the voltage increases on each one. Yeah, that's correct for gamma voltages. If you get like a situation where like you have 7.88 and 7.88 again, you get a very washed out picture. Or if like one of these is like reading, 12 or something too high, apart from the fact it might damage the panel, you'll get a washed out picture. But these are what that's what we've got. They're there, and I said earlier I would make a note and explain what gamma voltages are, and that's gamma. So when you see a washed out low contrast picture on a TV, that's quite possibly what it is. And check them, yeah? Okay. So this is what the voltage should be. Now, I have a look on this board, and I can see with this. Can you see? No, you can't see. Okay. I can see that there is a test point here. Let's try zoom it in, see if we can do it that way. One moment. Okay guys, so we can see under the microscope, this is the area of the circuit that we're interested in. This chip here is another one I can't find a datasheet for. It's a I7822 as a part number, but again, having a look on the internet, I can't find a datasheet for this device, unfortunately. So that's not going to help us either. You can see the number though, I7822. But we know that this chip, oops, sorry, I moved it too far. This chip is to do with the gamma voltage, and we've compared the gamma voltages on both the boards with these test points and these test points, and we get a nice ascending ladder of voltages. We have around this chip another inductor coil, a buck regulator coil. We've measured the voltage on this. In fact, I've measured it on this. It's about 3 volts. It's the same on both screens. We know it's the same. This part of the circuit, I'm pretty sure, is generating some of the other voltages we need. And the reason for that, in particular, although I can't find the data sheet, you see here we have D33, D32, D11, D12. These appear to be, because it's a D, it's probably diode, and I think they're like a diode network. So there might be like 2 pairs of diodes in each package. And if you look on the data sheet, sort of data sheet, the one that was given as a description for the voltages we should find. Let me just go back onto the screen. This is the voltage. It was given typical voltages, yeah, for this type of panel. And here you'll see there's some like diode networks with 2 diodes together, and there's other diodes in this circuit as well, yeah. There seems to be generally a number of diodes, another one here in this circuit, and this makes me think that what we've seen on these components here really sort of matches that, you know. We've got diode packages, yeah, and a chip, and that makes me suspect that this is generating the voltages much the same way that we can see in that example circuit. Now we have on here, if I can just find it, I found it before, some test points, and these test points, one of them is VGL, and we've measured it before. Where are you now? Yeah, so VGL is here, yeah. We've measured this before. It's minus 6.9 on both boards, and it kind of matches what that information is giving us, yeah. Also here is another one of the voltages we were interested, AVDD. Now that data information is suggesting that's going to be about 10 volts. We have 7.98 on here, so 8 volts. But again, it's the same on both boards. So that's 2 of the voltages. What I can't see is kind of like VGH, which that information suggests is going to be about 16 volts. And I said there's nothing on here that's 16 volts. But because the AVDD is 8, and that was suggesting 10, it may be less than that. It might be, you know, somewhere in the region of 10 or so. I'm guessing. We don't know what the voltage is going to be. But I can't see any test points that are marked as that. There's another one that says TVDD, and we were looking for a DVDD. But again, this is a test point that we've looked at before when I first went across the whole board, and I made the note of the voltage on this one, 2.54. So again, whatever it is, the same. In fact, we know all these test points are the same. So, due to the lack of data sheets, although I suspect from these diode networks this is the circuit, and I'm hoping you can see why I'm coming to that conclusion. I think the only thing we can really do now that we haven't done is measure the voltage on some of the capacitors in this area. Yes, there's a capacitor here. These things are capacitor networks. Yeah. I'm sure they capacitor networks. So that's like, you know, 3 capacitors in one block basically. That's a single capacitor. There's another one over here, another one here. So I think capacitors are a good place to look, because if you've got a voltage rail, the chances are you'll find that voltage on capacitors. There's some bigger capacitors, and this is AVDD. So I'm going to again take a photograph of the screen and just check all the voltage on these capacitors on each panel and see if I can see any difference. Okay, so I'll do that now, and then I'll let you know what I find. Okay guys, that was quite a worthwhile exercise actually. There we are. So I checked it on these capacitors because these are in the region of this coil, and generally in the region where we found one of the voltage of the test points as well. So I had a look at these, and we're getting 8 volts here, which we know now is this AVDD. In fact, the test point is there anyway. These capacitors have 3.198 on them, and they're the same in both panels. Interestingly, now I looked around in this area where we thought this chip, this area, and these diode networks were probably similar to that circuit we can see in that little tutorial. And interestingly, on this capacitor I actually found 16 volts, which is the voltage we were looking for, VGH, if that information is correct. Okay, that was saying 10 for the AVDD, and we had 8, but you know, it's in that region. And I found the 16 volts on here. That's the good news. The bad news is I found this on both panels. So really now, even from that information, we've exhausted the possibilities. We know now what voltages we should have on an LCD panel, and we've got them on both of them, and it still doesn't bloody work. So apart from the fact we've gained some useful knowledge, we're certainly no closer to fixing this thing. Okay, so we're going to have to leave that one there and see what you think about that one. Cheers now. So hopefully you've watched that video right through to the end, unless you just skipped it. But anyway, if you've watched it, you'll know by now that the reason I can't fix this screen is number 4. I can't work out what's wrong with it. Despite all my best efforts, despite having another kind of working one which I can compare with, so everything's in my favour. I've discussed online, and people have told me the most common reason, this fault has all the symptoms of a particular type of problem to do with EPROMs, which we've tried, and it isn't. At this point, we've really hit a wall with this one. So I'm going to have this laptop here for a little while. The guy is ordering another screen, a third screen. I'm confident the screen will work. I mean, the second one did for a while before it stopped working. So I'm confident. I said, yeah, get yourself a screen, it'll work. But in the meantime, this is going to be here maybe for a month or something. So if you have any ideas from this video of anything else you'd like me to try on this repair, let me know, and I will certainly try it and make another video with those attempts, and let's see if between us we can work out what the problem is and fix this screen. Okay guys, now it really is over to you.